Hi everyone. So in this class, we'll be having continuation of what we were having in the last class with respect to electricity. Under electricity, the middle part, which is your circuits. In that, we are dealing about the types of circuit. And in the previous class, we saw about series circuit. So the following to series circuit, which was introduced in the last class, which we'll be briefly seeing today, is your parallel circuit, right? So this is one classic question that you can find almost in all quizzes in your school level, or the teacher introduces to you. They generally ask this question like, if you were to build a house, what kind of circuit would you prefer? Okay, I know it's very basic. We all know the answer is going to be parallel, but what are the reasons you will consider it? And I stopped asking this question in the class because I got humbled by one of my students. He told, if I were to construct a house, why would I be thinking about a circuit? I'll just hire a good electrical engineer to get the work done. See, it's not wrong. He also is right, but it was just a scenario to put it across. Similarly, if we could come across similar scenarios, we would have given the answer as parallel. But why did we give it as parallel? What are the properties of parallel and what kind of numericals we can expect only from this parallel part is what we'll be seeing in this class. Clear? This is mainly focused on CBSE. Apart from that, even ICSE and IGCSE have this topic in common, so you can make use of it. Okay. So talking about this parallel circuit, first let's understand how design basically looks. So you'll be let's consider three resistors. This is your point A. It's a junction. Here I'll have one resistor. Here I'll have second resistor, and I'm having my third resistor. If you ask me if these are the accurate ways of drawing resistance, definitely no. Those we'll have separate class on which how do we draw circuits specifically for specific syllabuses. Whatever we learn in ICSE is not common for ICSE nor CBSE. Whatever we learn in CBSE is not common for the other two. So drawing specifically part we'll have in different videos. As of now, if you guys understand that these three are three resistors, which we call it as R1, R2, R3, it's more than sufficient. Okay, so this is how we count in parallel. See this part is just a shape. It could be like this, it could be like this, or it could even be a wire that looks like this, or it could even be a quarter circle that bends like this. It doesn't matter because it's just a piece of wire. The shape is specifically given. Most of the numerical shape is specifically given to confuse you. So what you need to focus on is the components and the junctions. That must be only a focus points, not the shapes. It doesn't matter what shapes they give. If you stick on to the components and the junction points, it will be easier for you to solve. Now I'll bring it down here. I'll have two cells, calling it as a battery, each of 2 volts, so it will be equal to 4 volts, or as of now I'll just write it as net voltage. Okay, so this is my positive side. The current goes in this direction and enters in this direction. This is my basic structure. So if I were to connect an ammeter, I could connect anywhere in the main circuit. To measure the main current, I could connect anywhere in this main circuit. For example, if I could connect ammeter 1 here and ammeter 2 here and one more time. What is ammeter? Something that measures current, and the resistance must be almost equal to 0. We always connect it in series. These two will give you the same values. We'll see it in that end of the class. Now, based on this, if I could connect a voltmeter, where will I connect the voltmeter? It will be across this voltage, right? I could connect a voltmeter here, or I could connect across these junctions, right? Here, 1 voltmeter also could be there because all my resistance are in these two common points. Now, talking about the general properties of this circuit, as you guys could see it, how many electrically common points we have for this circuit? We have 3 resistors, and for all the 3 resistors we have 2 electrically common points, which is connected to positive, other one is connected to negative. So generally, if you have only a parallel circuit, you will have 2 electrically common points. One is towards positive, one is towards negative, where all of them are connected together. So the first thing you will be writing here is, or understanding here is, voltage is constant. Why is voltage constant? Because all the resistors are connected to the battery directly. See R1, it is connected to the battery directly. See R2, it is connected to the battery directly. R3, it also is connected to the battery directly, because all of them are connected to the battery directly. Direct voltage supply. Next one. But if you trace the current, the net current from the battery exits here, and as it's entering the circuit, it splits into three parts. So in this junction, whatever current is entering is splitting into three parts. Again, it is joining back here, coming out together. So here we can tell that the current will splits. Current will split according to the number of path. If I have 4 paths, it's split into 4 paths. 5 paths, 5 paths. Here, since I have only 3 resistance and 3 paths, the current will split only into 3 paths. This is clear. So this is a basic understanding that voltage is constant, the current will split. This only itself a very huge advantage. Why? Imagine you have your TV, a bulb and an oven. TV, bulb and oven will require the same voltage. In India, it's almost 220 voltage. So if I could imagine this battery to be 220 voltage, all of them will get the same voltage, which is really good. And if you think about the current, TV, the bulb and the oven will require different currents. So this circuit to enable them to get their respective current according to their needs, because the current is what? Splitting. And how will the current split? Current will split according to the necessity. On which law? Based on Ohm's law. According to Ohm's law, if voltage is constant, how is I and R proportional? I and R are inversely proportional. How do I get this? I got it from V is equal to IR, which was your Ohm's law. According to this, I and R are inversely proportional, voltage is constant. So for example, let's say R1 is the highest resistance, it will have the minimum current. R3 is the least resistance, it will have the maximum current. That's all. Logic is simple. Now, to derive this series circuit, we have to start from current. The reason is that the net current only splitting into I1, I2 and I3. Clear? Talking about the voltage is constant. So according to Ohm's law, how will you find current? Current is given as voltage by resistance. But what is this voltage and what is this resistance? We got net resistance and net voltage. If we want the total current in the circuit, let's say it is A1 or A2. If you want the total current in the circuit, I should consider the total voltage and the total resistance. Clear? Total resistance does not mean 1, 2, 3 separately. It's the resistance of the whole circuit together. So that would be equal to, what is I1? I1 is nothing but the current through the resistance 1, which will be equal to voltage divided by R1 plus, what is I2, which is the current through resistance 2, that will be equal to V divided by R2. And what is voltage current 3? The current that passes through resistance R3, which will be equal to V divided by R3. And we know for a fact that V net is nothing but the total voltage. All the voltage will be same. I take V common out. So we got R net is equals to V into 1 by R1 plus 1 by R2 plus 1 by R3. V and we will cancel out. So in this case, in parallel, the net resistance is given as 1 by R1 plus 1 by R2 plus 1 by R3. That's it. Okay. So for example, let me assume the resistance are 2, 2 ohms, 3 ohms and 6 ohms. So how will I find the net resistance here? My net resistance in parallel will be equal to 1 by 2 plus 1 by 3 plus 1 by 6, and the LCM is obviously 6, so you will be getting 3 plus 2 plus 1 divided by 6, which is again going to be 6 by 6, which is 1 by 1. 1 by Rp is 1 by 1. So Rp also is equal to how much? Don't forget, you have to reciprocate in the end. This step is more important. 1 by Rp to Rp is more important. We'll make most of the errors in this part. It will be equal to 1 ohm. And if you consider this 1 ohm, how is this 1 ohm related to 2, 3 and 6? We can tell that this 1 ohm is lesser than 6, this 1 ohm is lesser than 3 and this 1 ohm is lesser than 2 also. So we can come to a conclusion that the net resistance in parallel circuit will be always lesser than the least individual resistance. The net resistance in parallel circuit will be less than the least individual resistance. So here the individual resistance is 2. So before I could start only, I can guess that the answer is going to be less than 2. And I got less than 2, which is equal to 1. So my answer is right. So like this, you will get some practical questions, competency based question. They'll ask you, if you connect a 1000 ohm resistor, a 100 ohm resistor and a 10,000 ohm resistor in parallel, what could be effective resistance be? And there is range of answers. Your range of answer must be less than 100, because we know that in your parallel circuit the effective resistance will be lesser than the least individual resistance. Clear? So what kind of questions we'll get in this part? Usually we don't get parallel separately, it will be a mix of both parallel as well as series combination. For that we'll have a next video coming up. But as of now, if you are lucky enough to get only a parallel question, you should focus on the part where we find the individual currents. Luckily, you have net voltage as constant, so you can just apply Ohm's law directly and find the answer. For example, I'll erase this part. If I have to find the current I1, I2, I3, how will I find out? How will I find I1? The currents I1 is equal to total voltage by R1. Clear? Total voltage is 4 and the resistance 1 is 2, which is equals to 2 amps. Okay. Next, my current I2 is equal to total voltage divided by R2, which is 4 divided by 3, which is somewhere around 1.3 ones are 3, 1.33 amps. Next, third part, third current is equals to voltage divided by the third resistance, which is going to be 4 divided by 6, which is 2 by 3, which is 0.667 amps. Okay. So as of now, the net current is 2 amps plus 1.33 amps plus 0.667 amps. This will be the total current given in A1 or A2. But individually, which one has the highest current? R1 has the highest current. Why does R1 have the highest current? Because the least the resistance, more is the current. According to which law? According to Ohm's law. That is what we have written here. We wrote here before erasing it. So according to that logic, it is splitting. Is this clear? In case if the three resistance were same, they will split equally. Since they are not equal, they are not splitting equally. So how will you find the net current? You can find the net current through two processes. Either you can add the net current as I1 plus I2 plus I3. This is one way. Or you can use a basic formula, which is I net is equal to V net by R net. Your net voltage is 4, net resistance is 1. So answer is how many amps? 4 amps. So if you could add all this 3, 2 plus 1.33 plus 0.66. 1.33 plus 0.66 is a value around 1.99999 plus 2, which is 3.999, but we got the answer as 4, which is pretty much close. So this is how you can get questions based on this, but I will suggest you not go into questions now. You can focus on the concept. What is the concept? The voltage is constant, the current is splitting, and same voltage can be used for finding the individual currents, and if you could add all the individual currents, you'll get the net resistance. Now we will do the same question with respect to equal resistance. In case, what will happen if all the resistance were same? If all the resistance were same, let's say All of them were 2, 2 and 2. For my convenience, I'll just change this to 6 volts. Convenience or to have a change, that's it. So in that case, now my new net voltage is equals to 6 volt. And what are my I'll change this to 3 ohms. 3 ohms, 3 ohms, 3 ohms. So all the three resistance are same. So what will happen? The current will split equally. It will be equal to I1 equal to I2 equal to I3. We'll see that. So how will you find net resistance? 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. What do we have as R1, R2 and R3 here? R1 is 3, R2 is also 3, R3 also is 3. So it's going to be 3 by 3. So Rp is equals to 1 ohm. Your net resistance is 1 ohm. So what will be your net voltage by net resistance? That's your net current. Net voltage by net resistance is equals to 6 divided by 1, which is equals to 6 amps, because I is equal to V by R. So you got the current as 6 amps. The 6 amp will split as 2 amps in this circuit, 2 amps in this circuit and 2 amps in this part. So if I add 2, 2 and 2, 6 will enter, split as 2, 2 and 2. Again the 2, 2 and 2 will join and exist as 6. So how do you prove that? We got I1 is equal to V divided by R1. Your voltage is 6, R1 is 3, answer is 2 amps. I2 is equal to V divided by R2. 6 divided by 3 is 2 amps. I3 is equals to V divided by R3, which is 6 divided by 3, answer is 2 amps. That's it. So if I have a meter 1 here, that also will show how many amps? 6 amps. And my ammeter 2 also will show 6 amps. Wherein my ammeters, if I could connect it here, here and here, it will show 2 amps, 2 amps and 2 amps, it will split equally. This is the logic behind your parallel circuit. So major takeaways are, in parallel voltage is constant. So all the appliances will get the same voltage because they all have two common points, electrically common points, positive terminal, negative terminal to the battery directly. Next one, the current is changing, that is it will split according to their necessities. High resistance will get low current, low resistance will get high current because there is multiple path to flow. If I want to find the net current, I can use the net voltage by net resistance. So to find the net resistance, I should the formula 1 by R1 plus 1 by R2 plus 1 by R3. And what is the final statement? Your net resistance in parallel will always be it will be always less than your individual least resistance. These are the major takeaways. In case you felt a little too fast in any of the part of the video, just pause and analyze the sum, you will get it 100% clear. So in the next video what I'll be uploading, I'll be comparing a series circuit and parallel circuit in your simulation, where we build it live and compare the outputs. Once that is done, then we'll go for combination circuits. Combination circuits is where we'll get the maximum questions from. Once that is done, we'll just have maybe 1 or 2 more sessions about the remaining part, which is energy and power. Post that, we'll spend more time for your numericals. Okay. Thanks for watching, children. All the best. Study well.